In this example, we're going to play a probability game. We have a bag that contains 9 yellow marbles, that will be event Y, 11 red marbles, that will be event R, 7 blue marbles, event B, and 6 green marbles, event G. So the first question we could ask is, well, what is the probability of not choosing a green marble? That's interesting. But what we're going to do is we're going to use a rule here. Our rule says that the probability of event G, that is our probability of a probability of not getting G, a complement of G, is going to be 1 minus the probability of getting a green marble. So how are we going to do this? Well, one good way to get your probability straight immediately is just to simply make a frequency table. We're going to do that. We have yellow, 9 of those kinds of marbles. We have red. We see 11 red marbles. We have blue marbles. There are 7 of those. And there are green marbles, and we have 6 of those. Well, if we add this up, we find that we have a total of 33 marbles altogether. So, the probability of each one of these is going to be the same. If this is our event, right, number, then our probability is going to be found by taking the event and dividing it by the total. So there's a 9 out of 33 chance we pull a yellow marble, an 11 out of 33 chance that we pull a red marble, 7 out of 33 that we're going to pull a blue marble, and the one we're interested in is 6 out of 33 of getting a green marble. So if we want to find the probability of our marble not being green, we're going to take 1 minus the probability that we do get a green. Well, when we work that out, let's see, 1, recall the decimal, the fraction rule, we get the common denominator, 3 out of 33, 33 of 33 equals 1 minus 6 out of 33 gives us a probability of 27 out of 33. But we're going to go ahead and round our decimal to 4 decimal places this time. And we're going to find that that's equal to 0.8182. So this is our probability of not pulling a green marble. Alright, well that was kind of fun, but it's more fun to pull in the bag and just figure out what's going to happen if certain events are going to go on. And we're going to say, we're going to do it one of 2 ways. We reach into the bag, we're going to pull out a marble, and we want to pull out a second marble. We're not going to look into the bag as we grab, we're just going to pull out the marble. So what is the probability of pulling out a green marble in the first draw and then another green marble on the second draw if the marbles are drawn with replacement? This means we're going to reach into the bag, we're going to pull out our marble and check it out. Is it green? Well, then we win. Then we're going to put that marble back, shake it up, and reach into the bag again. We want to find out what is the probability that that second time it's going to be green. How do we do it? Well, these 2 events are said to be independent because one is not going to independent, there we go, of one another. One is not going to affect the chances of the other. When that is the case, the probability of us pulling out a green marble on the first try and then a green marble on the second try can be found by direct multiplication. That is, the probability of us getting a green times the probability of us getting that green a second time. Well, we said it before, the probability of us getting a green marble is 6 out of 33. I'm going to reduce this fraction since there's a common divisor of 3. I'm going to tell you this is 2 out of 11. So what is my probability of getting 2 marbles that are green without replacement? Well, in this case, it's going to be 2 over 11 times 2 over 11 again. That direct multiplication gives us 4 out of 121, and we're going to give this decimal to 4 places. So that means our probability is going to be 0.0331. How about the next one? Well, now we're choosing it with replacement. That means we're going to pull out our green marble, but we're not going to put it back in the bag. We're going to shake up our bag in, reach in, and hopefully pull out another green marble. These are dependent events. When events are dependent, the way we calculate our P, G, and G is going to be different, right? The probability of getting a green and then getting another green will be equal to the probability that we pull out green the first time. But now we go back to the same model we talked about in question 2. That is, we're going to take out from there the probability that the marble is green, given that we just had a green in the first draw. So we green on the second draw, given green on the first draw. They're going to be different. How? Well, in the first case, the probability that we get a green, we already know. We've got a 2 out of 11 chance of pulling a green marble from that bag. But now we've removed those marbles. How many are left? Well, if we remove one marble, that means we've got 32 marbles. And where we had 6 green marbles to begin with, we've pulled out one, supposedly, on the first draw. So now we have 5 green marbles. So we now have a 5 out of 32 chance of getting a green marble on the second try. Well, how does that work out? Well, when we multiply these out and we convert it to our decimal, we're going to get 0.028. And that's our answer in this one.